Hey guys, and welcome to a new video. In this video here, we're going to load in some datasets, and then we're going to train a YOLOv6 model. At the end of the video, we're going to compare the results from our YOLOv6 model to the YOLOv5 and also the new YOLOv7 model. So we're going to see some really nice results. I'm going to show you how we can actually load in datasets. We're going to use Roboflow. Roboflow actually just released their Roboflow 100. So Roboflow 100 is basically just this multi-domain object detection benchmark. One of the good things about it is that they're actually using a lot of real life and real world data sets, where some of the other different kind of like benchmarks as Coco and so on, they're basically just like these general object detection benchmarks where they actually like have focus on like real world data sets. They have used and chosen some data sets from the public domain and like the public spaces here on Roboflow. So this is really cool. It's with the focus on actually like creating AI for the real world and the real life, and now they're creating this benchmark for it. We're going to use some datasets from the Roboflow 100. I'm going to show you how we can actually like load in those datasets. We're going to look at the GitHub repository. Then we're going to train a YOLOv6 model and actually compare the results from the YOLOv6 model trained on the Roboflow 100 datasets to YOLOv5 and YOLOv7. You're actually going to be a bit surprised with the results that we actually get from the YOLOv6 model when we're comparing it to YOLOv5 and also the new YOLOv7 model. So first of all, before we're going to train our models and load in our datasets, we're just quickly going to scroll through this article, Roboflow 100, a multi-domain object detection benchmark. So this is basically just like the article for the release of Roboflow 100. So first of all, to talk about like what is Roboflow 100, I basically just mentioned that. So here we can see the space of our datasets. So these are basically like all the datasets combined to one for the Roboflow 100 benchmark. So we have a lot of variety, and we also have different kind of like datasets for different domains. We can see the goal and the motivation here as well, because we have these like old-fashioned benchmarks as Pascal VOC, Coco, and so on for object detection. And now we actually like want to have more focus on real life, real world benchmarks. So here we can see the different kind of like categories and different kind of domains that we have inside the Roboflow 100 benchmarks. So we both have like some datasets for like aerial images, video games, microscopic, underwater. We have some documents as well. We have some electromagnetic real world. So here we can see we have 50 datasets inside of this real world domain. We also have the Coco down here at the bottom, so we just have one dataset for that. So it's basically just combining all these different kind of domains into like one benchmark. Then we can actually like benchmark our models that we have trained on more like general datasets, so we can actually see how good are our models actually like generalizing in general. So one of the most important things and one of the good things about this benchmark is the distribution here of these domains, and that we have a lot of different kind of like data sets in our real world domain, because we actually want to create some AI models that is used in the real world. We see some data collection, how they're actually collecting the data, what they're doing like with the pre-processing of the data. We can see some examples here of like underwater, aerial. We can see some brain MRI scans here, circuit boards. We also have a lot of other different kind of like domains. So all these domains here are basically combined into this one benchmark that we can use. And I'm going to show you how we can actually do that when we're going to train our YOLOv6 model. We have some data overview here. We're just going to scroll through it. We can see some data statistics as well. We can also see some experiments where they're actually combining these models. So they both have YOLOv5 model, YOLOv7 model trained. In this video, I'm going to train a YOLOv6 model, and then we can actually compare the results from this video on the datasets that we're going to choose from the Roboflow 100 benchmark. And then we can basically just compare to these results that they have. They basically have a paper, so you can just go in and read the paper as well. This article here is basically just like an overview and covering this paper. Here I'm just going to show you the paper. It's just called Roboflow 100, a rich multi-domain object detection benchmark. Here we can see the Roboflow 100 benchmark GitHub repository. We're going to clone that when we're actually like going to load in the different kind of things that I'm just going to show you in a second. We're going to use Google Colab to train this YOLOv6 model. Here again, we can basically just see the exact same things as in the article. We can also see how we can get started, how we can actually like clone this repository and set it up, but I'm going to show you that in just a second. If you just want to like fine tune a YOLOv5 model or a YOLOv7 model, they even have this clip model down at the bottom. Here we can basically just see some examples of how we can actually like fine tune these models on the datasets from the Roboflow 100 benchmark. So here you can basically just go into this GitHub repository, copy paste it and do the fine tuning, but let's now go in and act like train our YOLOv6 model. We're going to choose a number of different kind of like data sets from the benchmark here. Here we see some of the examples. You can also just go in here and see the original like repositories. If we just click on the link for the data set, we can basically like go inside this universe for Roboflow and see who created this original data set. We can go and download the data set. We can see like a description of it. We can see the different kind of like images and also all the annotations that we have in the images. So this is actually like really cool to just directly link to that. So you can go in and see the different kind of data sets before we act like training our models. So we're now jumped into Google Colab. I'm going to show you how we can act like load in the data set from the Roboflow 100 benchmark. So we're going to take a number of data sets from that. And then we're going to show you how we can set up the YOLOv6 model and also fine tune it. We're going to see the results and also some predictions at the end. Then we're going to compare it to the results with the YOLOv5 and the YOLOv7 model. First of all, here you need to choose the runtime, which we change the runtime to GPU accelerator. Then we just confirm that we have GPU access. So we're just going to run this block of code. Here we can see the GPU that has been assigned to us inside of this Google Colab. So we have a Tesla T4. So this is the GPU that we're going to train our object detector on and act like fine tune our YOLOv6 model. First of all, we're just going to set up our Roboflow API key. You can basically go inside Roboflow and take the API key. Everything will work for act like loading these data sets. So first of all, we set up our Roboflow API key. Again, you can basically just go in, find your own API key on the Roboflow website. You'll just need to sign up. Then we need to clone our act like RF100 repository. So this is the Roboflow 100 benchmark that I just showed you in GitHub. We're going to run this block of code. We will just cd into content, which is the directory here in Google Colab. Then we're just going to create a folder here or like the directory called Roboflow 100 benchmark. We're just going to clone the directory inside of that folder or inside of that directory. We go inside that directory and then we're basically just going to set it up, update it, and then we're going to pip install Roboflow. So over here to the left, we can now see that we have this folder called Roboflow 100 benchmark. We can see all the different things that I showed you in the repository. So we both have the YOLOv5 benchmarks and the YOLOv7 benchmarks. So basically we're just going to create this for YOLOv6 as well. We're going to see the dataset links down at the bottom. So we're going to use that to actually choose the dataset that we use. So here we just scroll down to the bottom. We can see that we have 100 datasets. I'm just going to extend this a bit more. Then we can just see all the datasets here that is inside the Roboflow 100 benchmarks. We're just going to choose a couple of those, train it on the YOLOv6 model, and then we're going to see the results. So here I'm just going to close these things and scroll a bit more down. Here we're basically just going to see what is actually inside our directory. So this is the exact same thing that I just showed you inside of the folders over to the left. Then we can also download all the datasets if you just want to like benchmark your model like to all the different kind of like datasets inside of RF100. You can do that, but here we're just going to download a number of selected datasets. So basically here we're just going to see 10 examples of the datasets from our dataset links 640 file that I just showed you over here to the right. Then we can basically just see a number of different kind of like datasets. We're just going to choose this soda bottles as I already have. Then we can basically just go down and choose that later on. You can choose like whatever dataset you want. Just go and choose it. You load it in with Roboflow, and then we can train our models on that. So this is really easy. It is actually really easy to actually load in the models and also to benchmark your models for these datasets here. Here we can actually just go inside our datasets. Then we're just going to have a Python script inside of our scripts directory. Then we have a Python file, download dataset. So we can actually download our dataset. We specify what dataset that we actually want to download and also the version of our dataset. And also here we need to choose the format of how we actually want our annotations to be and the format of our dataset together with both the images and also our labels. So here we're going to choose the YOLOv6 format. If you're using like YOLOv7 or YOLOv5, you should actually go in here and choose YOLOv5 without this MT. Then we just choose the directory or specify the directory where we actually want to download our dataset to. So here we're going to run this block of code, and now we can actually just download our dataset. We're loading the Roboflow workspace and also the project. So this is similar to what we're actually doing when we just export our models or export dataset from Roboflow, as I've showed you in a ton of other videos here on the channel. We just export it. We get a couple of lines that we just copy paste into our Colab. So this is basically what it's doing here. Now we're just downloading our dataset. So now we can see our dataset has been downloaded. We can go over to the left and now we have this folder with our dataset. We can go inside the soda bottles. We have the images, the labels. So this is the format that we actually want to have for the YOLOv6 model. Then we have the data down at the bottom. So this is basically just specifying like our training split or like our dataset split. So we have the test, train, and validation. If we just go inside test, we can see some different kind of like image examples of these bottles, or like these soda bottles that we want to have an object detector detecting. So this is actually like a really nice application and project as well. We can just see a number of different kind of like examples. So here we actually just want to have an object detector trained with the YOLOv6 model to detect all of these soda bottles in the image. Here we're just going to close these images so we can actually get started with the training and set up YOLOv6 and the environment. So here we're basically just going to go inside our directory. We're just going to ls that so we can see what is inside our directory. And this is just what I showed you in the folder over to the left. But now we're actually ready to set up our YOLOv6 model and our training environment for that. And then when we have done that, we can just start the training, let it train, and then we can do inference on our model after that. So now we're just going to download the repository for YOLOv6. So this is the link to the GitHub repository. And we're also going to install the requirements from the requirements text file that we have inside of that directory or like inside of that repository. We're just going to run this Blogger code and now it will actually just clone into YOLOv6. So or if we go over here to the left, we will actually just create a new folder with YOLOv6. And now we can actually see that we have done that. So we actually might be inside another directory here. So we might be inside the datasets or Roboflow here. Yeah, so we are inside the Roboflow 100 benchmarks. We can see that we have this YOLOv6 model. Here we can see all the different kind of things that we have cloned from the directory. If we go inside the tools here, which we're going to use later on, or not the configs, then we can actually see these Python files here that we're going to use when we're going to fine tune our YOLOv6 model. You can also train from scratch here. It just depends on what Python file you choose. You can choose these different kind of like models as well. So they have like some large models, some nano models, medium models, and also the small models. We're just going to use the small models in this example here. We also have a tiny model. So depending on your applications, depending on like how many parameters do you want inside of your model or like for your model, then you can just choose the different YOLOv6 models as well. So now we're just going to close this file explorer again. We can set up the model and the training environment. So now we're ready to train our YOLOv6 model on the custom dataset that we have. So basically here we just go inside our tools. We have the train.py file. We're going to use that to train our model. We specify the batch size. We also specify where are the configs for our actual training. So we have this YOLOv6 underscore fine tune. So we're just going to fine tune a model. We're not going to train it from scratch. So we actually need to go in and download the weights first of all. Then it will download the weights. We upload it here into Google Colab, and then we can fine tune a YOLOv6 model instead of training from scratch. It will take like a long time to actually train your models from scratch. And also if you don't have like enough data or like a lot of data, you won't really be able to get good results. So here we're basically going to use a pre-trained model, and then we're going to fine tune it on our specific data set. We can choose the number of epochs that we want to go through. We also choose the image size here. So we have 416 by 416 for our data size, or like for my image size. We also need to specify the data here. So where we actually have our data. So this just specifies where are our data actually in our directory. And then at the end, we specify the device. We're using 0, and then it will actually train the model on the GPU. So before we're actually able to train this model, we will go inside our directory here again, because we can see that we need to place our data file here inside the data directory. So if we go into the left here, then we have this data folder. We need to place our data.yaml file inside of this one here. So we're just going to do that. So we don't need to like specify it here in the whole path, or like when we're actually calling this Python script. So we have our soda bottles, we have our data file here. We basically just drag and drop it down to the data folder for our YOLOv6 directory. Now we have just moved it. So now we actually have this. We can then go into the YOLOv6 GitHub repository, and then we'll just choose the YOLOv6 small model. We're just going to click this link here, and then it will actually download the model to our computer. Then when we have downloaded the model, we need to go inside of our YOLOv6, and now we actually need to create a new folder. Here we're just going to call the folder weights, and then we just hit enter and it will create the folder. Then when we have created that folder, we just take our file and upload it to the weights here. So we basically just go inside our downloads, and then we just drag and drop it into our weights. and then it will upload the weights, and we can use those weights to actually like fine tune on our data set. If you don't have the weights or you don't upload them, you can also go in here and just like delete the fine tune here at the end, and then it will train a YOLOv6 model from scratch with random initialized weights. But here we're downloading the weights, we upload them into our weights folder. We need to make sure that it's actually like inside this YOLOv6 directory, and then it will use those weights to actually like fine tune on your data set that we have loaded in. So now when our weights is in the weight folder, we can then just run this block of code. It will run this train Python script. We have these different kind of like parameters that we have set. Then we'll also get a summary of our model, and then we can basically just scroll a bit further down, and then we will see the training process. So here we're just going to scroll down to the bottom. So this is the whole like this is the whole architecture of this model and the YOLOv6 model that we're using. So here we training start. We can see the epoch, intersectional union loss, and then we can also see the class loss and so on. We can see the mean average position of 0.5 and also 0.95. We can see the number of epochs. So here we're just training for 10 epochs. We can see the loss here. It's actually like decreasing over the number of epochs. We also have the batches. So we can see the batches. We have 30 batches out of 49. We have 49 batches that we need to run through for each epoch. We can also see some estimated time over to the right. But now we'll basically just let it run here. Now we can see that we are in epoch 1. We see the mean average position and so on, and then we will train the model, let it run here, and then we can actually see the results after that. We can do inference and compare to the other YOLOv5 and the YOLOv7 models. So now our YOLOv6 model is actually like done training. Here after 10 epochs, we're already at 0.81 here in the mean average position at 0.5. So this is the metric that we're looking at when we're actually going to compare to the results from YOLOv5 and also YOLOv7. So it took around like 15 minutes to train. We can actually just train it for a couple of more epochs, and we will get slightly better results. So this is not like fully converged yet, but it doesn't really increase that much for each epoch that we're running now. So this is actually like some pretty nice results. Now we can go down to the evaluation. Over here to the left, we can actually see the runs that we had. So here we go inside the YOLOv6 directory. We go inside the runs, train, and then we have the experiment. So here we basically just go inside the experiment. We can choose the weights that we have. So it likes like just load in the best weights. So now we go down to the evaluation. You can see all the different kind of like arguments that you can pass in here as well. You'll get access to this Google Colab notebook, so you can just run it yourself, try it out with the Roboflow 100 benchmarks, try some different kind of like data sets, maybe even like try out the whole data set if you have a lot of time. But here we're basically just going to run the evaluation. So we have the tools, evaluation, we choose the like data set, the image size, the weight. So here we basically just go inside our train data directory that I just showed you, and then we just take the best model. Then we're just going to run the block of code and run the evaluation. So here we can see that we're loading the checkpoint with using the model, and then we basically just throw our data set through it. So here we're going to add the annotations, and then we use the validation annotations. Now we're doing inference on our validation dataset, as we can see here, with 75% done. So basically here we're just passing our images through. So we have 16 images for this dataset, or like 16 batches that we're just passing through our validation. Then we're just basically just running through it. Here we can see like the average pre-process time, the inference time, so we can actually like see how fast are we doing inference with this model. So we have 3.65 milliseconds. So this is actually like real time. This is close to 30 frames per second, a bit under, as you can see. We also have non-maximal separation time here, which is 7 milliseconds when we're trying to optimize our predictions. Then we can see the average position here of different kind of like metrics. We can see the precision and also the recall. So we can see that we have some really good results for that. We see that the results are saved into our runs, val, and experiments. So if we just go in and verify that, we go inside our runs, we have the train, now we have the validation, we have the experiments, and then we have the predictions here in JSON. So now we're going to train one more dataset on the YOLOv6 model, and then we're going to actually like do a comparison with the YOLOv5 and also the YOLOv7 models from Roboflow 100. So basically here we just have another dataset called wall damage. We're taking version 2. I basically just already ran this code. So again, we're just downloading the dataset here called wall damage. We go over to the folder, and then we can see under our datasets, we have our wall damage, we have our images, labels, and I've already put like the data file under the data file here in YOLOv6. So we have everything set up now. We are actually just ready to train our model again, see the results, and then do the comparison to end off this video. Here we can just see the images. We have our test, train, and validation split. Here we just go out of the folder, we can set up our model and training environment. We already have that. So we have that from last. Basically here, we're just like taking in a new data set. We have downloaded data set and extracted it. Then we're just going to scroll down. Now we're ready to run the train Python file here again. I also made sure that we are initializing with the pre-trained weights. So these are not the weights that we trained the other data set on. Again, we just have the exact same parameters. Now we can just run this block of code and train this YOLOv6 model on this wall damage data set for object detection. So now we can see the training has started. Again, we're just running it for 10 epochs as we did with the last data set. Right now we're at epoch 1. We're just running through like all the batches. So here we can see that we don't have that many images in our data set. We only have like 11 batches that we need to run through, where in the other data set we had like over 40 batches. So we might actually need to go through more epochs here because we have a smaller data set that we try to like fine tune our model on. So 10 epochs for training this model here was actually not enough. I had to run it for 100 epochs. Here we can see that we actually end up with a bit worse results than we got. So we actually have a better model up here in some kind of like the middle after like around 80 epochs or something like that. Then we had some pretty good results, which is basically just like the best model that it will store. So we didn't have to like train it for that long. But here we can see that we have a mean average precision of 0.60, where for the other data set we had around like 0.81, 82. So we actually had a better precision, average precision on the other data set, but this data set here is also a bit different and often not like the normal like bounding box detection or like object detection that you have, because if we just go inside, for example, like the test images here, then we're just going to see an example of that. So here we can basically like see what we actually want to detect. So this is like, for example, like a crack. We want to detect wall damage, like damage on the wall. So basically like the bounding boxes will be very big. Like here we can, for example, like see the whole image. Then we will actually have a bounding box stretching through the whole image, and then actually like doing a detection for the whole crack in the wall, because we're doing this wall damage detection. So that will actually like increase our loss a bit, and also why our results might not be as good as with the other model. Down here we can go down and then do an evaluation. Again, this is still some pretty good results compared to like what type of data set are we actually like working with in this specific example. You can also like run some of the other different kind of like data sets here from Roboflow 100, and you will also get some better results and see some comparisons. But now we're just going to run the evaluation here. We're basically just going to run the exact same things as before. First of all, we just need to make sure that we go inside our runs. Then we have our train, and then we have experiment, and then we're going to use experiment 1. So I basically just have to go down here, experiment 1, then we choose the weights with the best training. So basically the training I showed you was the weights with the best like loss and mean average precision. So we're going to use that. Here we can just run this block of code and do the evaluation for this data set as well. So here we can see the evaluation results. Here we can see that the average pre-process time is really low. We can see the inference time is a bit more compared to like the last data set. It could be like, for example, that we have less images in this data set here, so we're then taking an average of the inference times, and that's why it's a bit higher. We also have the average non-maximum suppression time, which is lower because we don't have as many detections in these images here, so we don't have to like do non-maximum suppression as much as in the other data set. Down here we can also see like all these different kind of like evaluation results for the average precision and also the average recall for some different kind of like metrics, and also for the areas. So here we can see that we're basically like looking at like the large areas. We get some pretty good results for that. Down here we can see like the recall. We actually like have some pretty good recall as well. And that's basically because we're not getting as many like false negatives as we could in, for example, like other data sets where we have a lot of objects inside of our images. In this example here, we basically maybe just have like 1 or 2 detections inside of the data set, or like inside of the image. But again, the bounding boxes are really big, and some of them are actually like filling in like or like stretch out to the image boundaries and so on. So we will actually like get a bit lower precision because of that. And also like the intersection over union will also be lower, as we can see here. So now we can just, when we're training the model here, we're training 2 models on 2 data sets. Now we can go in and compare to YOLOv5 and YOLOv7. So I'm basically just going to go back to the article here again, and then we can see the results from YOLOv5 and also YOLOv7. We can see here that since the goal was to compare intra-model performance, we trained only one instance per dataset. So it's basically like what we're doing here as well. They used YOLOv5, the small model, and YOLOv7, the base model. And they were also pre-trained on a Coco dataset as we did in this tutorial here. So basically here we have all these different kind of like categories. We had the ones from the real world here because I want to like create AI models for the real world. I want to show you how we can actually like create that, use that, and then benchmark up against it as well. So here we can just see like the averages that we get. We can see the total. We can see here for the YOLOv5 model, for the first data set, we actually got way better performance compared to the YOLOv5 model, just in general down if we look at the total. And also for the YOLOv7 model, one of the nice things to actually look at here, and one of the things that you might actually like think a bit about, is that we actually get better performance with the YOLOv5 model compared to like the YOLOv7 model in general, and especially like on real world applications and datasets. We can also see we get a bit better performance on video games, aerial, microscopic. Here underwater, the YOLOv7 is better, and document is kind of like the same. But there's actually like some different kind of like domains where we get better performance with the YOLOv5 model, YOLOv6 model, and also YOLOv7 model. So that is one of the reasons why it's a really good idea to benchmark your models up against Roboflow 100, where we actually have all these different kind of domains. So you choose the best model for your specific application and dataset, because there can actually like be a lot of variation with the accuracy and also like the mean average position that you can get with the different kind of models for different data sets. We also had another data set with the wall damage where we actually like got under the other different kind of like average benchmark mean average positions that we have, but that is because it is a really specific case. This is also an odd data set compared to like some of the other different kind of like object detection data sets where we want to detect like smaller objects in the images, where here with the wall damage we detected like larger objects, sometimes filling out the whole image frame. So that can act like cause some problems with our loss and also our intersection over union and so on. So that's probably why we got a bit worse results. We can like try to train it. Maybe YOLOv6 is not good for that specific case. Maybe YOLOv7 or YOLOv5 is better for that. But we saw with the first data set with the bottles, like the soda bottles, we actually like got way better performance compared to like, for example, YOLOv7 and also YOLOv5 here when we're talking about like average, mean average precision for all these data sets that we have in the real world domain. Again, you could actually like try to train it for more epochs. We could maybe like increase the accuracy. I only trained the first data set on 10 epochs. We could maybe like get better, even better performance. The goal of this video here is also to show you guys that we can't just use like YOLOv7 is just a new model. We should just use that. There's the best model for everything. That is definitely not true. Like you should go in, like see what different kind of like domains are you working with. Go in, see some of the results here from Roboflow 100, then actually like make a decision on what is your domain, what model do I actually like want to use, how many parameters do I need in the model, do I want like do I actually like, it is kind of like this trade-off between like inference and accuracy. Do I want like a smaller model? Maybe if I use a smaller V7 model, I can get faster inference time, and I can also get better accuracy compared to the YOLOv6 model. But maybe I can get higher accuracy with the YOLOv6 model, but I also need to like have more parameters in a model compared to YOLOv7 model. So basically, like you can have an identical model where it has the same number of parameters as YOLOv7, YOLOv6, and YOLOv5, but you can actually like get better performance with the YOLOv6 model compared to some of the other ones, which is probably like the case that we just saw in this video here. So again, make sure that you're actually like looking at the domain that you want to do deep learning models for, what you want to do object detection for, what is your type of like data set. Go in here, research, maybe use this Roboflow 100 here as a benchmark. It is really good. You can see like the different kind of like stats that you can get for specific like domains. So if you want to do like real world applications, you should actually like maybe go in here, start with the YOLOv5 model, see what results do you get, and also maybe the YOLOv6 model. Then if you want to do, for example, let's say that we want to do underwater detection, we should maybe like try to use the YOLOv6 model and also the YOLOv7, because here we can see on average we get better results with the YOLOv7 model. But again, it also comes down to like the model sizes, the number of parameters, how fast you actually like want to run these neural networks here if you want to do real-time applications. Again, it all depends on these different kind of things. It's a trade-off between number of parameters and also accuracy on our neural network. So thank you guys for watching this video here. It has been really interesting to actually like train these YOLOv6 models on different datasets, compare them to YOLOv5 and YOLOv7, because this is actually like a really interesting discussion. What model should we use in what type of domain? Do we have some specific data set that is better for one model and the other model? And this video here, it just again shows that you can't just use the new model, you can't just use the new YOLOv7 model and say this is the best model, it's the fastest model, it's just the best model for every single domain out there. So again, benchmark it up against this Roboflow 100 dataset here. You can see the different kind of domains, try out some different models. And then remember to hit the subscribe button under the video here, guys, and also hit the like button if you like the content and you want more of it in the future. I'm doing a whole tutorial about like deep learning and all the different kind of things if you want to know how these things work under the hood with the batch sizes, how we can create neural networks from scratch, ANNs, CNNs, and so on. I'll link to the tutorial up here if you're interested, or else I'll see you next video, guys. Bye for now.